I did my homework this time. Actually read ahead a little bit. I think we should be okay. As far as getting through everything in one episode this time. I even did our notes ahead of time. On episode 36 here. Extending your Mongoose schema. We've got defining default values, using schema modifiers, adding virtual attributes, optimizing queries using indexes. So I think we should be able to power through that in an episode. Here's our Windows server back. It's gotten small. I didn't know it could do that. Let's see. That looks like as big as it can go. I guess I did know. Just don't usually keep what it says. So I can keep pushing it. I think that when it gets to the pixels of the screen that's on that system right now, looks like as big as I can go. It's the output of the system it's on. So yeah, we've still got these. Just be able to go ahead and fire them up because they've already, like I keep reminding, they've already got the code going, the code written. So we should be able to do a MongoD here, get our server up, and then we'll also do this one, this one. So we're still in chapter 5. We'll just do that again. We'll just node server and run it. Listening on port 1 connection, server running. Looks like we closed Postman, so we can get him running again. Well, I assume I might have read the text. Let's review the text and see if that's what we're using this time. Let's just start reading. Yeah, okay. Extending your Mongoose schema. Performing data manipulations is great, but in order to develop complex applications, you will need your object document module. Should have kept module in the term too. That's probably it. Operational data model. ODM Mongoose. Says we are on Mongoose right now. Object modeling. Translational research data, along with the associated metadata, administrative data, reference data, and audit information. Let's do one more. Let's do ODM database, ODM, 2 more. with Stack Overflow September 4th. It's probably the same question. It's higher ranking for some reason. Probably, I may just reference it. Object Document Mapper. Object Relational Mapper. Maps the relations between data, whereas ODM deals with documents. Am I right? Assuming that my SQL is an example of ORM and my... I'm sure you can see I'm not too familiar with the theory of the concept. Could someone please clarify the difference between the two? It's an example of a relational database you can use in ORM to translate between your objects. Code. Search the data examples. An ODM for MongoDB. Dango. So I wonder for Mongoose. Okay. ODM module. Should just be the module that does what we looked up for ODM. This is, okay, looks like ODM is still Mongoose. I was just curious if it was like something that was like another layer to it, but looks like Mongoose is an ODM. So, and apparently Mandango is too. Okay, whatevs. Acronym police. Just curious what that was. To do more. Luckily, Mongoose supports various other features that help you safely model your documents and keep your data consistent. Defining default values. Defining default field values is a common feature for data modeling frameworks. You can add this functionality directly to your application's logic layer, but that would be messy and is generally a bad practice. Mongoose offers to define the default values at the schema level, helping you organize your code better and guaranteeing your document's validity. Let's say you want to add a created date field to your user schema. The created date field should be initialized at creation time, and the time at which the user document was initially created should be saved. A perfect example of when you can utilize a default value. To do this, you'll have to change your user schemas. So go back to your app models, user server model file, and change it to look like what is shown in the following code snippet. Require mongoose schema equals mongoose schema, constant user schema equals new schema. Right here we're adding this created type date default date now. Okay, which will already be there. Note how the created field is added and its default value field and its default value defined. Created type default created type string type date. Okay. You should also note that every document created prior to the schema change would be assigned a created field representing the moment you queried for it, since the documents don't have the created field initialized. To test your new changes, run your application using the following command. We've already done that. Then use your favorite REST tool, Open Postman, to issue a post request and execute the following command. Users post okay. Just don't know what the little d represents. copy that. 10 for good copy. Okay, so we do a new one. Wait, we're going to users, aren't we? Gonna copy that one. Duplicate current tab. So users, post, body, raw, JSON application. Control V. Send. Created 9/5 Greenwich Mean Time. Awesome. Can we go back to users? Just do a get for our users. Just had one last time. We should have just loaded a new one. Doesn't show their created time, but they're both there. I didn't change any of this guy's stuff. Username, full name, undefined, user@example.com. Alright. A new user document will be created with a default created field initialized at the moment of creation using Schema Modifiers. We're on to our second note with almost the halfway mark. Sometimes you may want to perform a manipulation over schema fields before saving them or presenting them to the client. For this purpose, Mongoose uses a feature called modifiers. A modifier can either change the field's value before saving the document or can represent it differently at query time. Predefined modifiers. The simplest modifiers are the predefined ones included with Mongoose. For instance, string type fields. You can have a trim modifier to remove white spaces, an uppercase modifier to uppercase the field value, and so on. To understand how predefined modifiers work, let's make sure the username of your user is clear from a leading and trailing white space. To do this, all you have to do is change your app models user server model file to look like what is shown in the following code snippet. Type string, so username. Instead of just saying username, email string, we're saying type string, but we're adding trim true. So if you just need one, you can do string. And they're both capitalized, in or out. Default or set. So what happens if you just put, I guess you gotta put string somewhere. Okay. So basically they're just adding trim true. Note the trim property added to the username field. This will make sure your username data will be kept trimmed. Custom setter modifiers. Predefined modifiers are great, but you can also define your own custom setter modifiers to handle data manipulation before saving the document. To understand this better, let's add a new website field to your user model. The website field should begin with HTTP or HTTPS, but instead of forcing your customer to add this in the UI, you can simply write a custom modifier that validates the existence of these prefixes and adds them when required. To add your custom modifier, you will need to create the new website field with the set property as follows. Set, let's see, all that website, adding an object, type string, set function URL. This isn't just a set type, website type, set. It's an interesting one, set type, set function URL. If not URL, return URL. Else, if URL index of HTTP, if not equal 0 and URL index of HTTPS not equal 0, URL equals HTTP plus URL. So basically, if it don't have this or this in front of it already, then go ahead and concact that to the beginning of it and return that after it's been concacted. Now every user created will have a properly formatted website URL that is modified at creation time. However, what if you already have a big collection of user documents? You can of course migrate your existing data, but when dealing with big data sets, it would have a serious performance impact. So you can simply use getter modifiers, custom getter modifiers. Getter modifiers are used to modify existing data before outputting the documents to the next layer. For instance, in our previous example, a getter modifier would sometimes be better for changing the already existing user documents by modifying their website fields at query time instead of going over your MongoDB collection and updating each document. To do this, all you have to do is change your user schema as shown in the following code snippet. To me, some of that looks like it's been bold again, but I guess not. We can actually do an inspect to find out. I think we can. Strong. So I thought, yep, right there it starts. It's the first one. Website type string is still the same. But they're adding that getter function. I see it now. If still looks very familiar. If not URL, return URL. Else, if URL index of concact return. Looks like they're doing something very similar. They just moved it over. But then if we're adding the getters, true. Okay. Eyes are getting tired, or old, I guess is the more accurate word. Couldn't tell it was. I thought it looked highlighted, but I couldn't tell for sure, or bolded, but I couldn't tell for sure. You simply change the setter modifier to a getter modifier by changing the set property to get. However, the important thing to notice here is how you configured your schema using user schema set. This will force Mongoose to include getters when converting the MongoDB document to a JSON representation, and will allow the output of documents using response JSON. In order to include the getter's behavior. If you didn't include this, you would have your document's JSON representation ignoring the getter modifiers. Note, modifiers are powerful and can save you a lot of time, but they should be used with caution in order to prevent unpredicted application behavior. It is recommended that you visit mongoose.js.document js.com documents API HTML for more information. Open a new tab. I'll bookmark it before we close out. We're good on time, right? We're almost at the bottom. Adding virtual attributes. Where are we at on our playlist? adding virtual attributes. Sometimes you may want to have dynamically calculated document properties, which are not really represented in the document. These properties are called virtual attributes, and they can be used to address several common requirements. For instance, let's say you want to add a new full name field, which will represent the concatenation of the user's first and last names. To do this, you'll have to use the virtual schema method. So a modified user schema would include the following code snippet. Virtual full name get function. Return this first name plus space plus this last name. So you're concatenating. It's a function to concatenate. User schema set to JSON getters true, virtuals true. In the preceding code example, you added a virtual attribute named full name to your user schema, added a getter method to that virtual attribute, and then configured your schema to include virtual attributes when converting the MongoDB document to a JSON representation. However, virtual attributes can also have setters in order to help you save your documents the way you prefer instead of just adding more filled attributes. In this case, let's say you wanted to break an input's full name field into your first and last name fields. To do this, a modified virtual declaration would look like what is shown in the following code snippet. Set function, full name, constant split name equals full name split on spaces. This first name equals split name, index 0, let's see, or space. This last name equals split name index 1 or space full name split space on space split name. Virtual attributes are a great feature of Mongoose, allowing you to modify document representation as they're being modified through your application's layers without getting persisted to MongoDB. Optimizing queries using indexes. It's our last one. Got just enough time. Great. As we previously discussed, MongoDB supports various types of indexes to optimize query execution. Mongoose also supports the indexing functionality and even allows you to define secondary index. The basic example of indexing is the unique index, which validates the uniqueness of a document field across a collection. In our example, it is common to keep usernames unique. So in order to convey this to MongoDB, you will need to modify your user schema definition to include the following code snippet. Username, type, trim, we're adding right here, unique, true. This will tell MongoDB to create a unique index for the username field of the user's collection. Mongoose also supports the creation of secondary indexes using the index property. So if you know that your application will use a lot of queries involving the email field, you can optimize these queries by creating an email secondary index as follows. Email type string index true. Another minute. I think we can do it. Yes. And we got a minute for a paragraph. Indexing is a wonderful feature of MongoDB, but you should keep in mind that it might cause you some trouble. For example, if you define a unique index on a collection where data is already stored, you might encounter some errors while running your application until you fix the issues with your collection data. Another common issue is Mongoose's automatic creation of indexes when the application starts, a feature that can cause major performance issues when running in a production environment. Ba-dum-bum. Alright, 30 seconds to spare. Where are we at? We got defining custom model methods, model validation, using Mongoose middleware, using Mongoose reference fields, and summary. So if we can keep pace, if we can do one episode, so we just hit 4, that'll be our 4th one today. So it's our first 2 hours, 3rd hour, 4th hour. So by noon, of the midweek, by the lunch break on Wednesday, we would be through the first 5 chapters. So holding that projection, we should be here by Friday. And we were going to do a 50-hour work week instead of like around 48 maybe. So somewhere around 96 to 100 episodes we ought to be ended up with automating and debugging. And then probably won't spend any time on the index. I've already looked through it. It's basically yeah, it's there if you need it, but it'll basically, it's not anything to read through. So I'd say we're right on schedule. Creating a mean CRUD. So we figured out how we were doing the CRUD through Postman. So over these next little bits, we're going to be building the CRUD in the front end. We've already got our back end working pretty smoothly, and the front end even allows like a Mongoose interaction, but we'll basically replace the Postman interaction with an Angular app on the front end. So basically, when they go to our website, our code will be the interaction that lets them do what they're trying to do with what we're simulating with Postman now. So very exciting. Not as exciting as watching code dry, but just knowing where all the pieces fit together and work together smoothly, I think it's fun. Hope you're enjoying it, and if not, the process is still helping me. So, thanks.